So suppose you want to derive the following formula. P implies Q and not Q. So we have P implies Q, conjunction not Q, and this whole thing between parentheses implies not P. So that's a formula we want to derive. And you can see that this formula is similar in some sense to Modus Tollens, because what we're saying is P implies Q, so this is right here. Then we're saying not Q, and then we say therefore not P. This is Modus Tollens. So this formula is essentially a horizontal version of Modus Tollens, which is vertical, but they're very similar. So how can we go about deriving this formula? Since it is an implication, it has an antecedent, so this whole part here is the antecedent, and then there is the consequent, which is on the right-hand side of the arrow. Anytime we need to derive an implication, we assume the antecedent and we try to derive the consequent. So let me write the formula here at the bottom. So it's P implies Q and not Q implies not P. So this is our goal at the very bottom. And immediately above the last line, I should write not P, which is our consequent. And then somewhere on top here, somewhere as one of my assumptions, I write the antecedent of the formula. So I'm going to write it here. P implies Q and not Q. So this whole thing between brackets. And this is my assumption, and I'm going to call it assumption number 1. Okay. So the goal is to get from this assumption number 1 to not P, all the way down here. How am I going to do that? There's no immediate way to do it, also because here I have P implies Q, I have not Q. What I want to get at is not P, so there isn't any immediate way. Now, one thing I can do to get closer to close the gap here is to rewrite not P according to my notational convention. And so remember, the notational convention when it comes to negated formula says that if you have something like not A is the same as A implies the contradiction. So this is our notational convention NC, and so I can use it here, and I can write not P as P implies the contradiction. Now here there is something interesting because I have an implication. And so my goal now here becomes to derive P implies the contradiction from my assumption. And whenever you have to derive a contradiction, the rule is always that you assume the antecedent. Sorry, whenever you derive not a contradiction, but whenever you derive an implication, the rule is to assume the antecedent. So in this case, the antecedent is P. So I can write above here the symbol for the contradiction, and then write somewhere here my assumption P, which is the antecedent here of the implication, and I'm going to call it number 2. Now, here I can do something. So how about I can start trying to close the gap between what I want to arrive at and the assumptions that I have. So from my assumption number 1, I can apply the rule of conjunction elimination, and out of the two P implies Q and not Q, I can get P implies Q. Now, if I have P implies Q together with P, through implication elimination, I can get Q. All right, now something is happening. I have Q. How do I get to Q from Q to the contradiction? Well, there is something interesting here because I have not Q right here. So assuming that I can get not Q, and this will be something that you need to think about, how we can get to not Q. Assuming that you can get to not Q, well, Q and not Q will give me the contradiction. So I'm very close to be able to arrive at the contradiction. Now, how can I get not Q? Well, that should be easy. I can assume again assumption number 1, somewhere here on the right, and instead of take out P implies Q, I take out not Q. So let's do that somewhere up here. Hope it's not too messy. So I'm going to assume it again. So I'm going to assume P implies Q and not Q. So I'm just repeating assumption number 1. So I'm not doing anything new. I'm just repeating assumption number 1. But in this case, through conjunction elimination, I take out from here not Q. I can do that because I have conjunction elimination. And now, thanks to my notational convention, I can write, so this is my notational convention here, I can write instead of not Q, I can write Q implies the contradiction. Now I'm done. I have Q implies the contradiction. I can put these two things together through implication elimination, and I get to my contradiction. Q implies the contradiction, therefore the contradiction by conjunction elimination. There is a little bit of white space here. It doesn't matter because I put my assumption a little too up in the air, but there is no problem. So I think I should be done. So what I can do now is to check that everything is correct, and in particular I should check that my assumption can be cancelled. So I started with this assumption 1, P implies Q and not Q. By conjunction elimination, I got P implies Q out. Then I added next to it this other assumption, P. This I called assumption number 2. And by implication elimination, I got Q. On this side here, on the right-hand side, I assumed again P implies Q and not Q. And by conjunction elimination, I got out not Q. I applied the notational convention, so not Q is the same as Q implies the contradiction. Now I put these two things together, Q and Q implies the contradiction, and by implication elimination I get contradiction. Okay, I arrive at the contradiction. Now I can cancel one of my assumptions, namely P. So I can say that P implies Q. So I can do that with implication introduction, and I use implication introduction onto my assumption number 2. So I can put the number 2 here, and I cancel my assumption here. By my notational convention, I can say that P implies the contradiction is the same as not P. Now I'm almost done. I got to not P. I need to cancel the assumption that I have up here. P implies Q and not Q. I repeated this assumption twice, but it's exactly the same, so I can cancel both of them. And I use implication introduction to assumption 1, and so I derive at the end a P implies Q and not Q implies not P, which is precisely what I want to derive. So everything works, everything checks out, all my assumptions are cancelled, I follow the rules that I could follow, and so I'm done.